Hi, everybody. Sorry I can't be there with you today. I didn't realize I had a training. In any case, let's see what I can do about section 2.5 to get you guys through it. I've already talked to you that this means that we're going to take the derivative. What we say in calculus is that we're taking it with respect to a particular variable. The variable down here is at x, so we say it's with respect to x. If I want to take the derivative of a function called y, I will call it dy dx. Now, when I'm looking at the rule that we created the other day, we said we could take the derivative in this way. And it is now going to formally be called the power rule. If you look at another set of notes from a different day, we also wrote down that if you take the derivative of a constant, you get 0. But this one's my favorite. It's called the scalar multiple rule. It means if there is a constant out in front of my function, when I want to take the derivative of it, I can just take the derivative of the function and then multiply by that constant later on. So you will see me do that in just a moment. Also wanted you to know that a function can be taken the derivative of it if there's a plus sign in between. All I have to do is take the derivative of the first piece, take the derivative of the second piece, and then put the plus sign in between it again. So it comes really natural. Watch me do it, all right? If I take the derivative of x to the fourth, I bring the power down. So I'm going to have a 4x, and I'm going to reduce that power of 4 down to a power of 3. So that's the basic derivative. Now we've done this with some negative exponents too, so I'm hoping that you're feeling okay with it. I'm going to say that I have a negative 2/3 power, and that x is being reduced down by 1. So I have negative 2/3 minus 1 is going to end up being negative 2/3 minus 3/3 ends up being a negative 5/3. So I say my new power is going to be negative 5/3. And then when I take the derivative of a constant, I get 0. And I just wanted you to know that. Now I'm leaving it in unsimplified form because I don't have the time. So you guys please do finish the negative 5/3. And if you're having trouble with that, when you see me again, I'll be able to help you. So h of t, by the way, this next one, number 3, it has the negative 2t cubed in the denominator. In order to differentiate it, it's easier to think about it like this. Negative 2t to the negative third power. And now I can take the derivative of it. The derivative of a constant is 0. I'm going to say I have a constant out in front, and now I just want to take the derivative of t to the negative third power. So the negative 3 comes down out in front. I have t, and it is going to have a power that has been reduced by 1. So I took away 3, and now I'm going to take away another, and that gives me a negative 4. When I'm all done, this one I'm actually going to simplify for you. Ready? I have negative 2 times 3 is negative 6. And then in the denominator, I have t to the fourth, and it is positive. Okay? This last one, notice that this, again, I have a common denominator here. It is a 3. So I want to rewrite this. I'm going to say this is 5 times, ready? 2x is being taken to the cubed power, but it is a negative 2. Wait, hold on a second. You know what? It would just be easier if I go ahead and cube that number, wouldn't it? So I'm going to say this is really 5 over 2 cubed is 8, and x is being cubed. Do you see? I have this constant now, and I'm going to leave it out in front when I do my work. So I'm going to say this function is really equal to 5/8, and x is to the negative third power. So when I take the derivative of it, I'll get an f prime of x, and I'm going to have a 5/8 out in front. This is me using the scalar multiple rule. I'm going to say then that I'm taking the derivative of just plain old x cubed, so I have a negative 3, and x has a new power, and that power is reduced by 1. So negative 3 minus 1 is a negative 4. When I try to, work this out, I'm going to end up having a negative 15 over an 8, and x is going to be returned down to the denominator with a positive exponent of 4. So I'm hoping that this feels pretty basic, right? And that you're like, oh, yeah, I remember these examples. Okay. What about all of this? Did you know that you can take the derivative more than once? So if I take the derivative once, I call it y prime. If I take the derivative twice, I call it y double prime. But honestly, after that, I say the third derivative, I say the fourth derivative. And look at how there's a crazy little 4 right there. Sometimes I will see teachers actually write it like this, y with a 1, 2, 3, 4 prime marks. But you can see how it's a little bit unwieldy. This is the notation that is going to kill you later. I promise you, you will forget what it means that there's a d squared here and there's an x squared there. The idea here is that I took d dx and I am squaring it with respect to a function that is called y. And so that's why there's a 2 here, and all of dx is being squared. That's why there's a 2 there. Don't worry, I'll cover this again. For now, just be able to take the derivative twice. That's important, okay? I will show you that hopefully in a moment. So anyway, when I'm taking the derivative of this crazy looking example number 5, how can I go about doing that? Well, first of all, I need to actually take the derivative, okay? How can I take the derivative when there's an exponent and a radical in the denominator? I'll change it. Make it be something that you can remember and recognize how to use the power rule on it. So I'm going to say that this is 1/2. That's my constant. It's out in front. I'm not going to deal with it again. Not until the very end. But this right here, this is really x to the 2/3 power, and it's in the denominator. So I'm going to bring it up to the numerator. I'm going to say it's a negative 2/3 power. Now I can use the power rule on it. And I'm going to go slow because I did that in class and I hope you liked it. I have a constant. That constant is 1/2. I have n. n is negative 2/3. Yay. What about n minus 1? Because I do need to decrease that by 1. I will say that it is negative 2/3, and I'm going to take away something that is equivalent to 1 that has the same denominator as what I have. So I'm going to end up with a negative 5/3. So when I'm trying to put together this derivative, I say I have that rule, remember the one that we introduced in class, with a constant times n with x to the n minus 1. If I am taking the d dx of x to the n that is being multiplied by a constant. This is the rule that I have memorized, okay? I'm going to use that rule and I'm going to put together my derivative right now. F prime of x is ending up being a 1/2, and n is a negative 2/3, and x is going to be now to a new power, which is negative 5/3. 1/2 times 2/3 is a negative 1/3. X is to the negative 5/3 power. I really thought I'd picked a good spot to tape, but somebody's talking behind me, so I'm going to let this be the end.